So, welcome everybody. I hope you're excited to start hacking. It's fun. I have some experience there and I liked it a lot. So, I want to help you with TLS Notary. So, I'll start the first part just introducing what TLS Notary is, and then I'll give a very quick demo to get you started. But we also have a booth at the Ethereum Foundation. So, if you have further questions, you can find us there. So first, the motivation, why would you consider using TLS Notary? So I assume everybody knows HTTPS. So TLS is the S, the secure in HTTPS, and it's used to get data, Alice can get data from a website. What is data? It could be identity information from a government website, it could be balance information from a bank, it could be social information or just gaming stats that you want for bragging, for example. So what TLS is a very helpful way to get data securely from a website, but it doesn't have a solution for sharing data with a third party, which I will call Bob in today's talk. And so Bob could be a KYC provider, a creditor, somebody who wants to use that data. And so what I expect for in this hackathon, most of you will have the perspective of Bob, where you want to help Alice to provide her with a service, but to do that you need some information from her. And so, as I said, TLS, make sure you can get data securely from that website so you know its origin, you know but nobody changed something in between in that channel, and also that nobody can listen in. But because it uses symmetric encryption, you cannot simply pass on that data to somebody else. And so that's where TLS Notary steps in. So we have a solution where Alice and Bob can do the TLS transaction together. And so it has all the properties of TLS, but in addition, it makes sure that Alice can pass on her data to Bob securely. Bob does not have to trust that Alice doesn't cheat. He can check it. And also, it does not need any changes to the original website. So this kind of unlocks all existing data on the internet, and your app can compose different sources and provide, implement new applications that way. So what's the secret sauce of TLS Notary? We do the TLS connection with the multi-party computation. So that means that Alice and Bob have to do all the key exchange together. And so the advantage is that Bob, during that TLS connection, only sees encrypted information. And at the same time, Alice cannot do any requests or decryption without the cooperation of Bob. So Bob also knows that Alice cannot cheat. Of course, there's no free lunch either, so there is a cost. So there's definitely higher latency in that connection, and also there's a high bandwidth, so lots of encrypted messages that needs to be exchanged between Alice and Bob. But the good news is it works in a lot of cases. So I told Bob only sees encrypted information that would be useless. After the TLS connection is closed, Alice can then share the actual decrypted data with Bob, and so TLS Notary has an option there to offer redactions. So what I showed here with the red squares is that that's kind of information is redacted when Bobs get the data, but still Bobs know that the unredacted data is all correct. It's not easily available yet today, but you will also be able to do zero knowledge proofs on that data that's hidden. So instead of disclosing your address, you can give information about it's not in the US, for example. So in a nutshell, so if you want to share data in a secure and privacy preserving way, consider TLS Notary for your hackathon projects. So use cases is everything where both privacy and security are important. So things like identity, financial information. So you could prove real-world assets, like you could make your user log in to the Tesla website or to whatever website to prove he owns stuff. or that he bought stuff in certain stores if you want to have like a marketplace. Or also, like I heard somebody at the booth earlier said they were looking into like gaming assets stuff, or like gaming statistics, all this kind of things become available to do stuff and combine it in new ways, even if the website doesn't offer an API for that itself. So again, the data becomes composable. So it's already used in the wild. So ZKP2P did a hackathon in India where they prototyped this. It's now available online. OpenLayer did a hackathon in New York where they built this bragging website where you could prove your GameStop wins or losses, which is nice. And Opacity Labs made something with data from 23andMe where you could prove your Neanderthal index or your inclination towards baldness. In the previous version, there was only 3 parties. Sometimes you want reusable proofs where both verifier A and B want it. In that case, you can separate the MPC, the multi-party TLS, to a trusted neutral party, and then have the prover store that proof. And then if the verifiers trust that notary, they can actually use that proof without being online together with the prover to do the actual TLS transaction. So now let's switch to the demo. For the demo, I'll show you our browser extension. Oh, sorry. The advantage of the browser extension is that, so to log into websites, you often need the cookies. And we have prepared a demo here where we will prove that we received a DM message from myself to the TLSNotary account. So when you click this, you get this checklist with steps, like first make sure you're logged in, and then it needs, like you need to select a direct message. So when I do this, I can click the check button here, and now it starts notarizing, so checking this request. So I'm now using a notary service on my own laptop to make sure it's fast enough and we're not limited by network speeds. And then you get this proof where you see, I don't know if zooming in works, yeah. So where some stuff like access tokens can be redacted, and then you get the response, and there should be my GM is in there. That's the response we got for the service. So now we have this signed data that your app could use. So this is extensible. So if we switch to VS Code here, you see that you can implement TypeScript where we have a config.json where you configure the steps that needs to be done. They each have then an implementation where you check whether you can move to the next step. And it also has some, but that will change in the future, but already has a permission system where you also kind of protect the user of not having crazy plugins that steal all the user's data. But it's already very approachable for you to start developing plugins. And then the most interesting part is mostly that you need to get access to cookies. So in this case, it's from the Twitter servers. And then you compose a request where you set the necessary headers. So for example, here we reuse the authentication token that the browser was using, and that way we get the response we need. And we can even do some redaction in there. And then it's just a matter of, if only I could type, to do a build. And what's actually happening here is we built a WASM plugin. I don't know if you heard of Xtism before, but it's not that important. But now we can open this build result, which we can now add to the browser extension. We can add a plugin here. And then, yeah, it's already in the correct location. So the user gets some information like don't just install everything. So this one will have access to these kind of cookies. We'll allow it now, and now I can run this proof that I have a Twitter profile. So the proof should arrive shortly. I think I sped run through my demo. What also important to know, so that's the site to get the data. Of course, your app will also want to use that proof to verify that the proof was correct. So if you go to the TLSN extension repository, there's we added the wiki for this hackathon, where we also have this TLSN Connect provider, where you can, as a website, connect to our extension, request access to proofs. Then you get, again, you need the user consent, and then you can verify the proof and use that data in your application. Either it's to do something on-chain or off-chain. TLSNotary is very flexible. Only your imagination is the limit, and also the data size. So if possible, look for APIs that give you just the result that you need, and not like, if it's server-side rendering, that's too much data for TLSNotary to handle today, but we're of course always pushing that limit. Kilobytes. Yeah. So like the lower kilobytes are no problem, but then like 50 kilobytes, that's already starting to get tough. Yes? Well, so the request is to the upstream server, so... Oh, at the verifier side, there's no problem. But so the limit is because it's all so MPC, that's like garbled circuits, oblivious transfer, so there's overhead in there. And so there's lots of communication between the prover and the verifier. If you do it with the notary, then it's similar with the notary. Worth mentioning is that at PSE, we do run an example notary server. So in the hackathon, feel free to use that. The documentation is on our website. So that's definitely an option. And then for the hackathon, we have 2 bounties. So TLSNotary itself is written in Rust. So feel free to also just implement a server that's something funky in Rust, or use our new plugin system to just fetch the data, do something with it. So we have a prize pool for new plugins, so that just like figuring out how do I get data from the data sources. And if you have new use cases, yeah, that's also, we're very curious, like what you guys will build with it. So in that case, so the question is, what if there's extra features in the backend? So in most cases, I think you can solve it with selecting the correct cookie. If they, of course, they can change their API any day, and then you need to update your plugin. But that's also painful for them. And of course, also, please respect the terms of services of the data source. This is not a hacking tool. So yeah, also keep that in mind. Yeah. Yeah, so there's this trust assumption. So What does it mean? So imagine that the prover is running the notary, then we're back to square one. And then it doesn't help. So the notary needs to be neutral. If it's two parties and they collude, again, so if it's about a lot of money, it's more careful. You have to be more careful than if it's just like, if you need to have a Tesla to be in an anonymous Tesla chat group, it's not that bad if somebody cheats, but if this is a multi-million-dollar deal, then you need to be more careful, definitely. There are already startups like looking into like eigenlayer solutions with slashing if notaries cheat. But we're also like looking into doing like, this is like a two-party computation. Like it's possibly also possible to have like, do your request, if it's high value, do your request with 10 notaries. That will be probably a high cost then, but if it's worth it, it could be so. I'm not sure why that's relevant, but so there are solutions. You could also run a notary in trusted environments. There's all kind of research also going on there, but maybe we should discuss that at the booth. Yeah. Yeah, more questions. Oh, I have to wrap up. Sorry. So for more questions, visit us at the booth. That's also where the real experts are. I'm only the spokesman. So thank you for all the good questions, and I wish you a good hackathon.